So first of all, welcome. Today's session is about introducing HyperProtect, and it's being presented by Jen, Francis, and what we would like to encourage is questions. And if you have questions, if you can put them in the chat room, that would be great. If you don't want to type it out because it's a long question, we're quite happy to basically, well, I'll be quite happy to unmute you and let you just ask the question, but questions as we go along. And the one thing I would encourage you at the end is to actually leave feedback. And the session here is 1AS, and please do leave feedback at the end. And what I'm going to do now is hand it over to Jen, and thank you very much.
All right.
You will get your foils up. Yeah.
Yep. All right. So hello, everybody. I am going to go ahead and share my PowerPoint. And we'll actually go to the title slide. So good afternoon. Good to see everybody. So we are going to talk about HyperProtect today. And really we're going to start with talking about why there's a need and the underlying technology that makes HyperProtect what it is. If you were able to join me last week, I did an introduction to containers. This would have met your chili pepper requirement for this session. It would have actually prepped you very nicely to come into this with just a good understanding of containers and how they are being used, but also some of the risk associated with them. This is session 1AS. I do have the QR code at the bottom of the slide. So if you have the app on your phone, I think you can scan it. Or if you just have a browser on your phone, or I think your camera, if you have an Android phone, you can scan that QR code and leave session feedback. You'll also find it at the end. But please do leave feedback. It's good to know what we can have more information on or other things that we can have for next time, so we can make GSE very meaningful for everybody. All right, so for today, we're going to talk about what is confidential computing. If you haven't heard this term before, you'll start to hear it more and more. It used to be something I would randomly hear, and now I hear it quite often. And then we're going to talk about what is IBM HyperProtect and then how you can actually use this technology. All right, so what is confidential computing? Trust. Trust is a funny word. According to the Merriam-Webster dictionary, it means to rely on the truthfulness or accuracy, maybe to place confidence in something or someone, or to hope or expect confidently soon. So we put trust in a lot of things. We're putting trust in this session that it's going to be webcasted, that we're going to be able to hear, that we're going to be able to see. And that's a pretty easy trust to give. You know, if you look at the second definition for trust, it says you could commit or place in one's care or keeping. You know, if you trust somebody with a secret or something like that, that's often a bit harder of a trust to give. When we log into something online, we place trust in whoever that service provider is, that they are protecting our credentials, that whatever information we are seeking from them, that they have been securely storing that. So trust is a funny thing, and it's something we give often very complicitly. So should we be asking any questions? And what things are the most important to you to really have, you know, trust for? All right, so let's take a look at the issue. All right, so I created a little scenario for us. So in this scenario, we're looking at a cloud, or at least a shared system. So we've got customer A. They're running, let's say, 5 containers, doesn't really matter, but they're running some number of applications in containers in an environment, and they're running on top of a hypervisor. We also have customer B running some number of applications, probably in containers and an environment somewhere, also running on a hypervisor. Whenever we log into a cloud provider, we often don't think about the fact that we actually are running on a shared system. So unknowingly, we have in common with whoever else is on a hypervisor, that same hypervisor that we're all hosting our applications on. So I know most of us probably aren't commuting these days, but it is a bit like commuting. So whether you're maybe on a train to London, or maybe you're on a plane or a bus around town, whoever you are seated next to, you're now sharing basically the bus with. Whoever's near you, you're sharing the bus with. And generally, you're pretty self-contained and you're fine, and it's just going to be a journey, and it's fine. Maybe sometimes you get to chatting to the person near you and you end up with a best friend, or maybe that person next to you is coughing or wiping a runny nose and touching things, and maybe you end up with some cold that you're stuck with for a week. But generally, we all kind of live in our little self-contained bubbles and we share space and it's fine. And occasionally something kind of creeps through that shared space and we end up with, maybe a good thing or maybe a bad thing. The same is true on the cloud. You're running containers, you're sharing a hypervisor. Potentially, there could be a risk that you could share something good or bad. So if I'm running in the cloud, are there questions I should be asking? So first of all, let's look at storage. If I'm running on a hypervisor, they are going to be storing my information for me. Is my storage encrypted? How do I know? What about the applications I'm running, whether I'm customer A or customer B? Those applications that are being deployed, how do I know that they're the exact ones my team wanted deployed? How do I know that they are the tried and tested, been through all the QA, that they are the ones intended for production? Can they be verified? Should they be verified? What about the site reliability engineer, the SRE that's running the cloud? Can they access my customers' data? Can they just SSH into the hypervisor? I mean, typically I would expect that, yeah, they probably can, because that is the reality of how most of us are going to maintain a system. But is that bad? Is that a risk? Can they see my customers' data? What about how thick are the walls? So what do I mean by that? So I'm running containers. If you're familiar with containers at all that use runc, or even let's I'll pick on Docker. Docker was a good example I gave last week, just because most of us are the most familiar with Docker's implementation. So Docker runs a daemon process that is generally going to have root privileges. Depending on how the environment's configured, your container could also be running with root privileges. So if my container has root privileges and it's writing to my environment, and that is going to be writing to the hypervisor, is there a risk of privilege escalation? And then is that information going to be available that other people can see it at the hypervisor level? So are my walls that thick? Are they the kind of, paper walls? Or let's look at like the 3 little pegs? Is this the one that the wolf is going to be able to blow down? Or is this going to be the brick house that is going to be a lot harder for the wolf to get through? And then we've already talked about, am I on that shared hypervisor? And who has access to it? Do the other customers? Is it just the SRE? Like, how do I know? Who can I trust? Because you're asking me to trust a lot of people. I don't even know who they are. So how do we address these concerns? And at this point, we can never build something that is going to be completely intruder proof or risk adverse, but we are going to try to mitigate whatever risk we possibly can. We are going to be like the third peg in the story of the 3 little pigs. We want to have, the brick house. We want to make it as solid as we can, and try to make it harder for people to come and steal our data or come and take information about us or create issues for us. So what are ways that we can mitigate risks? So my storage being encrypted. So with customer B, we could see them pointing to a cylinder, assuming that is a storage device. So could we have an offering where the storage is encrypted with keys that never leave the box? That could be interesting. We know it's encrypted. The keys are protected. They've never been exposed to the internet. That could be helpful. What about the application images? How do we know that they are the ones that we intended to deploy? Maybe we could use an offering that has the ability to deploy applications through things like Docker Content Trust. And there's a link there for Docker Content Trust if you're unfamiliar with it. But some of it is basically you do sign an image and you authenticate with Docker Content Trust, and you pull based off like a hash instead of just saying, I want to pull this, Docker image and potentially getting, maybe a slightly different version than you intended. And then what about the SRE? Can they access my data? So we need a solution that's going to remove all of their access methods, because generally we want to be able to trust our providers, but practice has shown that people get upset, or maybe they get, compromised, that they get an offer they can't, turn down. And all of a sudden, the person that we should have been able to trust maybe isn't the person we could trust. And then how thick are those walls? We don't want to be like the first piggy who's building his house out of sticks that gets blown down. We want to build those thicker walls. We want to be that third piggy. And we want to try to look at building thicker walls by using other options other than run C. So we want to remove the risk of having our containers running with root authority, or having a process that they are communicating with that are going to have root authority. So what are the ways we can do that? Are there options available to us that we can run containers that have basically, the more sturdy walls to reduce risk? And then what about our hypervisor? So if I run in the cloud, I am probably going to have to share a hypervisor, but could it be more secured? Could it be, restricted? Could it have perhaps a secure REST API? That's the only way you can access hypervisor, so people aren't just kind of accessing and looking around and trying to see what information is available. And this is where the idea of confidential computing comes in. So according to the IEEE, confidential computing uses hardware-based techniques to isolate data and specific functions, or even an entire application from the operating system, hypervisor, or virtual machine manager, and other privileged processes. So data is going to be stored in what they call a trusted execution environment. So if you ever see the acronym TEE, it's your trusted execution environment. So the data is going to be stored there, and when it's there, it's going to be possible to view the data or operations performed on it from the outside, even with a debugger. So this really starts to address a lot of the issues that have come up with running in this public shared environment, or even if you're hosting a shared environment within your company. We want to limit who you can see that customer data. Why? Because there's so many regulations we're all facing. So if we know who exactly can see that data and has access to that data, we can start to eliminate the areas that we need to audit and to prove who has access to that, to show that we are meeting the government regulations. And this is where HyperProtect comes in. So we're going to go ahead and introduce IBM HyperProtect. So if we go back to the idea of this trusted execution environment where we're going to have basically, everything secured, we're probably going to have cryptography involved. And when you have cryptography, you're probably going to have keys, which means you need a secure way to store them. Which naturally leads us to the Ibm Z hardware. Why? Because we have this HSM, a hardware security module, that is FIPS 142 level 4 certified. And so this becomes this purpose-built piece of hardware that you can securely store keys in. So this is a nice picture of it. So inside this HSM, there's no physical security mechanisms that are required. It does have features that show evidence of tampering. So this is to have this 140 level 2 or 142 level 4 certification. So no physical security mechanisms required. You have to have a way to show that something's been tampered with. So maybe it's coatings, maybe it's sealed, but we want to know if somebody tries to mess with this HSM. We also need to be able to prevent an intruder from gaining access. We also need to have a way to provide a complete envelope of protection around the cryptographic module, including environmental protection. So there's within the FIPS 142 specification, there's various levels. I think it goes up to level 5. But basically at level 4, you know, even if you're trying to digitally tamper with it, not even a physical tampering, we know that this HSM that's got a crypto processor within it is going to protect itself and zero out. And we want to know that anything stored in that is going to be so protected. And this one is. So this is starting to give us those really secure brick walls, maybe even kind of like the vault type, where you're going to have the thick walls and a good tight turn on the vault to protect everything within it. So now maybe we can use something like this HSM with this thing called a secure service container, or really you'll hear me call it a secure enclave. So this is going to be that kind of thicker walled container. So this is the, you know, the brick house, and now we're going to put basically kind of a vault on it to make it even more secure, or at least for where we're going to put the keys. So maybe it's a vault inside the house. So what is a secure enclave? So this is essentially a hosting appliance that is signed and encrypted at build time. So we'll take a look at what that's going to mean here in a second. But it's built through a secure build running on a hosting appliance. It's going to have a secure boot with a root key and the protected memory. All the data disks are going to be encrypted. The root keys for the appliance are going to be inserted by secure build. So we'll take a look at that. Within this, you can run an image. It's going to be locked down for ease of use. It has updates to replace all the code and preserve the data, and the data is going to be separated across volumes. You can still do backup and restore. You can export and import encrypted workload backups to things like Cloud Object Store. And you can run dynamic workloads. So this is basically deployed as a virtual machine. You can run things that are packaged and signed by Docker. So this is where you could use things like Docker Trust to know what's running inside the secured environment. So let's dive a bit deeper and take a look at what this actually looks like. So this is basically just looking at the kind of hardware level of the environment and what's going to happen. So this is the boot sequence. So if you're familiar with Z Hardware at all, you have this SE or service element, and you could potentially authenticate with the service elements through a smart card. And when you do, you're basically going to then pass a machine secret. And so you're going to say, let's boot up this secure enclave. And here's my key to show that I have the access to do that. So the bootloader is going to verify my secret, and it's going to then be able to load that into memory. So when it's going to load that into memory from disk, it's going to check the integrity of the software bootloader, and it's going to decrypt that software. So we're now on this kind of second gray box with the software bootloader. Within that, oops, we also have a key for disk encryption. So we are going to go ahead and start encrypting and decrypting what's done in flight for accessing the appliance code and data. And we're going to end up with a software image that's got an encrypted disk, and it's a Linux virtual machine. So because we have encrypted software, because we have encrypted data, you can only manage this appliance through REST APIs. So you can't just SSH into this. So everything that you're going to do is going to be done remotely, and you're going to talk and authenticate to be able to do that. So we're going to have the secret that we pass to show that we are a trusted person and we can actually do things in this environment. All right, so let's take a look at, we've got this kind of secure service container. We've built that gray box. So now if we want to actually deploy workloads to it, what does this look like? So we want to, let's look at, so we're going to have out on something like Docker Hub or Docker Content Trust, we're going to have these images. And really, we probably want to have those verified. So we're going to have some type of key or really secrets and registration file that we can use to access our container logic. So we're going to have those encrypted for the appliance, and it's going to be able to talk to the gray box. And from that, we can use the Docker REST API to look at a local registry. And really what's going to happen is when we go to say something like Docker run, and we're going to say run this Docker image, instead of using something like run C to start up our container, we're going to use something called run Q. And what run Q does is it actually puts a basically KVM or a virtual machine around the actual container. So there's another layer of isolation. And then within that container, you're going to have things like your data volumes for the data. You could have databases. You could have something like blockchain that's running chain code. You could have whatever applications you wanted in there. And then you can see the arrows down to our data volumes, and they're going to run an encrypted data pool. So not only are we running in a securely booted environment that can't be accessed. So this is our basically our hypervisor. I'm sorry, I have an Apple mouse, and every time I move the mouse, it also likes to move the slide. So we've got the secured hypervisor now. We've got a verified way of pulling an image in, and then we're actually going to run with those thicker walls. So we're not just going to run a container within a secured hypervisor. We're actually going to isolate the container more and make those walls thicker by having it run within its own virtual machine. And so when you go to access it, you won't know the difference, but you actually have a greater level of isolation from those around you. If you want to understand more about run Q, you can click the link on the bottom of the slide to find out more information. All right. So how does this all flow? There's lots of keys involved. So we're going to start with the little gray box called hosting appliance on the left. So this is something like a secure build server. And it could have something like an appliance to vendor key. It could have a vendor to appliance key, an appliance to appliance key. So basically, this is the place that we are going to have the ability to talk to the HSM and work with those keys so we can talk to all of the different areas that we might need to. So whether it's pulling an image from a vendor or just talking to the appliance, this is where we're going to be able to do that. So with those keys, we can actually go down to the bottom, cylinder where the appliance image is, and it's going to look at the appliance code disk. And because we've got the proper keys, we can do that. And we can then actually, go look at the appliance configuration. It's going to have what's called a quota group. So this is something that you create to be able to secure the data. It's basically how we know that where each virtual machine is going to talk to or which quota group they're going to talk to. So we have the keys for that. And potentially we could even have cloud object storage that is maybe storing some of our keys so that's easier for the vendors to talk to, and that can actually talk with our HSM as well, so that the keys are actually stored in there. So our virtual machines are going to be able to start up. They're going to have those encrypted data volumes. It's going to basically have those data volumes configured based off of the quota group, which we've now mapped to storage that's going to be encrypted. And that's going to go all the way down to that appliance data disk at the bottom. So we're passing, keys around for authentication for everything that we do, just to keep everything very secure. All right. Any questions before we start into what the offerings are? All right. So here are the offerings we're going to talk about today. So these are IBM Cloud HyperProtect services. So they are on IBM Cloud, and one of them you can actually also run within your own data center. So we're going to start talking briefly about the HyperProtect crypto service. So this is a service where you're basically going to work with our HSM to store your keys for cloud data encryption, but it is going to be protected by the HSM on IBM Z. The next offering is HyperProtect Database as a Service. So in this offering, you have a database that's going to run within that kind of container, within that virtual machine. So when you access it, all you see is a database. So you get either Postgres or you get MongoDB. And it's just like you're accessing your database, but it's going to be very secured around it. And everything it's going to write to is also encrypted so that if you're using a database in the cloud and you are working with something that requires a lot of data confidentiality, maybe healthcare, maybe financial records, that everything is absolutely protected, that somebody can't see it from the outside end, and that everything is encrypted, whether it's in flight or at rest. And then we're going to talk about how the HyperProtect virtual servers work. So these are Linux VMs. You provide a key, so you have your own public SSH key to maintain access to the data and code. It started off with just an Ubuntu server, so you could request it's in the cloud, and it would be just like logging in with a key to an Ubuntu server anywhere, but you know that's more isolated, it's better protected. But now you can actually bring your own image as well. So you don't have to just use Ubuntu if you've got a different image that you would like to use. Maybe something like blockchain is a great one to use as an example, or maybe you just want to use a different operating system. You can actually do it. You can bring your own image and deploy that to the HyperProtect virtual server. And even more fun, this is something I've been doing a lot of work with lately, is working with HyperProtect virtual servers on your own premises. So this isn't offering that in IBM Cloud, but it is basically the same technology. So it's going to be the same secure enclave and the same ability to run containers within that. But you can actually run and do that yourself. So maybe if you're in an organization that is doing a hybrid cloud, you might want to use some things already in cloud offerings, whether it's IBM's or somebody else's, but you may also want to have the ability to administer some of this yourself. So this offering absolutely gives you that, because you could create your own database as a service inside virtual servers or something like that, or create whatever it is that you need. And you could actually set up the secure enclave and everything yourself. All right, so let's get started. So all of these HyperProtect offerings are going to be built on top of the secure enclave or secure service container, but in particular, the crypto services as well. So potentially you could have some number of customers. They're going to have a dedicated key store. They're going to have a key protect API around that to be able to work with their key store that's running in the secure enclave, talking to a specific HSM domain. So each customer will have their HSM domain. And within that is basically what is going to be called a crypto service crypto unit. And those are going to work with the HSM cards on the IBM Z, or really our Linux One platform. So this is the FIPS 142 level 4 compliant HSM domains. So it's going to be the highest physical protection of other secrets. So we don't export the master key at all. And customer root keys are in having your customer root keys in clear as possible. The idea is with this is the idea called keep your own key. So a lot of cloud-based HSMs or crypto services want you to bring in your own key. And the risk of that is somebody has that key and they could have copies of that key. So how secure is that key? It's like if you give a key to your house to somebody and you say, hey, can you give this to different technicians that are going to come do work for me? Maybe it's the mastic man is going to come do some work, or maybe it's a tiling guy, whoever it is. If you give that key to your house to somebody, how do you know they're not making copies of it? And how secure does that key become? Because basically, we don't know. Like, anybody could do whatever they want with it. You've just given them, the keys to everything. So with keeping your own key there, having it, generated and protected within the HSM, you know exactly who has access to that key. So you really are securing your environment. So just a little bit of a look at how it works. So once again, this talks about the keep your own key. You have a master key that's defined using TKE. Your keys are going to be protected, or you're going to be able to access your keys through the Key Protect REST API. And there is a low-level grep 11 API also as well. So as a developer, as somebody that's just going to use the keys, I can just access through calls to verify the keys. But underneath, everything is completely covered and backed by the HSM. And Sandeep, I know that you're on. I don't know if you want to talk a little bit more about what you'll dive into tomorrow in your session. That's at 3 o'clock GMT.
Yeah, sure. So my session tomorrow is going to cover how we're going to manage secrets using IBM Cloud HyperProtect crypto services. And by secrets, it could be API keys, it could be certificates that you want to store, passwords, and all that, and how IBM Cloud HyperProtect can come together in different use cases that I'm going to cover tomorrow at the session, which is session 4AZ. Sign up for that one, and I'll have more details for you tomorrow. Thanks, Jen.
Yeah, thanks, Sandeep. All right. So looking a little bit forward to the session tomorrow with Sandeep, but before we get to Sandeep's session tomorrow, we're going to talk a bit more about the other HyperProtect offerings and how they can be used. So this is looking at the database as a service. So once again, you're going to have the databases running inside the secure enclave through those thicker walled containers backed by RunQ. So within this, let's say whether you're running Postgres or MongoDB, you're going to have a primary and 2 secondaries. And the environment is going to be fully managed. Your encryption keys never leave the secure enclave. You do have encrypted logs and storage. So you're going to have, your one primary database and then the replicas for failover or HA or whatever it is that you need. So it makes it really easy. These are ones that I've got to play with. It makes it really easy. If you have people that are MongoDB experts, but you know that you need the security, they can use their same MongoDB tools. Whoever has access to the cloud for your organization, they can set it up. You give them the proper endpoints and the public keys that they'll need to be able to access it, and they're on their way. And you can actually control the roles that they have and things like that. So it really is just as easy as setting up a MongoDB somewhere else or a Postgres database somewhere else. And then getting into the fun part, HyperProtect virtual servers. I love these just because there's so much you can do with them. So when you go to the IBM Cloud and you request a virtual server, you do configure it with your key so that you can SSH into this virtual server. So the key is going to be inserted into the server image, but it's not accessible by the site reliability engineer. And all your ports are going to be closed by default. But once you get that set up and going, it's just like working with a normal Linux system. I can do whatever it is that I need to. And so basically your possibilities are endless at this point. All of the hard work is done for you in the cloud. You provide the key, it spins up a server, and you're ready to roll. So let's look at what this looks like. So let's say we've got some type of, talks about the open virtual machine. So we've got, maybe two clients, maybe some number of clients. And this is kind of a different image of what we started with. We had customer A and customer B. So it doesn't show that they're just running on a hypervisor anymore. So now they're running in this secure enclave. And there is still, a Docker image there that you can access through RESTful calls. They're going to be secured RESTful calls. You're going to have some way to authenticate with it. But then we also have those thicker walled virtual machines that are going to be running, because we're not just running a container. The container's actually got a greater level of isolation because it's within another virtual machine. So it shows within the KVM. And because when you set up the virtual servers on the cloud, you also have to provide keys to access that virtual server. You can only authenticate with what you have access to. So it is locked down. You know that the site reliability engineer or an admin cannot get into your VM. There's just no access from the bottom up. You can access, into your specific guest, but nobody else is going to be able to get around you. So it's basically like having your own train car on the train, or maybe your own bus to yourself. but it gives you that greater level of isolation. So you are still, running in a potentially shared environment, but you've got a greater level of isolation. So I don't have to worry about, maybe today I don't want to make a new friend, or, I don't, want to be at risk of having a bad cold. Maybe I just got over one. So this is that kind of greater level of isolation as those brick walls that's going to make it harder for somebody to get into. All right. So what is the difference between the cloud and if you run it yourself? Other than the obvious, if you run it yourself, you have to actually run it yourself. But there's some little differences that we'll talk about. So you're going to need some type of trusted kind of continuous integration, continuous deployment stages, because you're going to have to bring your own image. You're going to have to sign, register, approve, and deploy it. So you have these, life cycle phases. You've got, code development, and then you're probably going to do a build and pre-production and production. Maybe there's QA in between there. Whatever those things are, at some point you end up with an application image. And typically that image is going to be built from some type of source code repository. So kind of basically what you're going to do is, instead of just building a normal container, we're actually going to want to build it in a way that we can verify that container. So we're going to deploy or develop an image, we're going to upload the source files, and then we're going to generate what's called a secure build. And so at that point, we're going to sign off on it. And eventually you could have third-party endorsers and things like that. But then we're going to really, at this point, we're going to need some type of security endorsement. So we're going to look at a manifest and see what's there. See if there's a Docker image for it. See if there's, maybe we've registered through something else, not Docker Content Trust, but some other secure kind of repository for images. And make sure we have the permissions and that the particular specific file that we want is there. And once we know that it's there and we have access to it, we can then deploy that through automation. But we are going to look at a manifest to do that, and not just say, oh, we want version 1.3.7. We're going to look for very specific hash for which image we want. And this is all going to be done through RESTful interfaces. All right, so just kind of a step through the secured build process. So when I set up HyperProtect virtual servers to run on premises, you work through this thing called a management server. And it's through that management server that you could then integrate a secure build process. So we have this developer, and they are going to use this kind of CI/CD pipeline to create a securely built image, and they're going to put it out to Docker. And then we're going to configure Docker Content Trust to then be able to talk to our HyperProtect virtual server. And in the future, we could have an auditor, verify and inject audit capabilities into this. And they would have the ability to maybe endorse that, yes, this is the image that's been through all the checks, it's good to go. And they could have their bespoke endorsement and exchange of keys. And then we get a summary endorsement back to the virtual server. But today it very much still looks just without the auditor. You create your container, you do push it up to Docker, you can sign it and store it in Docker Content Trust. And then when I want to deploy it to the virtual servers, I can pull that from there. And I've authenticated with that. So I know that it's a specific repository and it's a specific image I want. All right. So how is HyperProtect being used? Quite a few ways. So we're going to talk about some of the different combinations of technology. So we have the crypto services that gets used with the Kubernetes service secrets. So Kubernetes can provide secrets to the idea of pods. And I am making the assumption that everybody understands what a pod is. But basically, pods kind of group your different containers together. So the idea is with secrets is that you have data that could be like a token or a password that an application inside the pod needs when it stood up, but it shouldn't just be stored inside the Docker image that it's created from. So instead, that secret can be pulled from a controlled location that Kubernetes provides, which is great, except that you still actually want to protect that data. So with this type of integration, that secret can actually be stored in our CryptoProtect services. So it's going to be backed by that HSM and safely secured. So you still can read that secret, but we just have a better way of storing that secret because we don't actually want it in that Docker container. So all cloud-based, all easy to do and configure through APIs. All right. A lot of people have been using the HyperProtect crypto services with the cloud object storage. So basically, this is just general object storage. So you could use that cloud object storage for like a binary blob or maybe backup and recovery of your applications or data archiving. So when you would set this up to work together, you actually create more places to put data into via an API. And you can drive that API to push object data in and get it back out. But because you're now storing data in there, you can actually be storing sensitive data. So this is where you'd want to integrate with crypto services to actually encrypt the data while it's stored there. So if you're needing that kind of object storage and you've got a particular application with sensitive information, this is definitely something you'd want to look at. So we've been working with a client that's using this for secure file storage. A user of their service actually uploads a file, and then to be encrypted, they encrypt it using a key that's derived from their password. So the encryption is done on the fly, or can be done on the fly through the integration with the crypto services, just by pushing that file into the cloud object storage. All right. And then let's talk about how you would use something like the crypto services with the IBM Cloud HyperProtect database as a service. So when you create the database as a service instances, you generate a storage encryption key and keep it in the secure enclave where it can't be accessed. So that's simple to use and it's very secure. But if you already have a crypto service and you want to take advantage of the FIPS 142 level 4 compliant hardware for your database storage encryption key, you can actually do that by using it with crypto services. So when you create the database as a service through the cloud, you can select your crypto service instance and have the root key to use for the envelope encryption. So this is actually useful if you're going to use the crypto service for other purposes too. So maybe you're also using that IBM Cloud Object Storage or something like that. So it becomes your centralized one key management strategy. As with other types of integrations, the key exchange is done for you by IBM Cloud, and the key data is never made accessible to the cloud infrastructure teams. So it's still highly secure. But it now fits into your key management strategy and you're not having to manage keys in lots of different areas. So we've been working with a customer who's intending to use this. They have security features. They wanted their security features that we're actually able to offer through this integration, and it actually appeased their security and compliance team. They weren't able to do this on other clouds because they didn't have this level of security. So it wasn't getting through their security and compliance approval process. They needed the reinforced or the enforced storage encryption and the integration with a highly secure HSM. So this actually allows them to do things in the cloud that just wasn't possible before because it didn't meet their standards. And this is going to be looking at just the virtual servers as a really simple example. So it's just a Linux server in a highly secure environment, but there are a few things that we want to call out. So first, you should really always have some type of continuous integration, continuous delivery pipeline to build your application, since you want this to be locked down and secure. if you're going to run a Linux in such a secure environment, you should have everything going up to that also be really secure. Otherwise, you're starting to minimize having, a secure house, a nice brick house with a vault-like lock on it. So this is really true if you're going to run containers to install maybe, on premises and maybe use Docker containers. So the key problem is that Docker only builds images for its architectures that it's running on. So when you want to build a container for Linux One or for IBM Z, you have to have a S390X host. So in this situation, you can actually take advantage of the HyperProtect virtual server in the cloud to actually build your production ready image for public cloud. You could also use this maybe for dev test purposes or for training or to reduce the cost or time of overhead to do some things on-prem that might have more approvals. You could just, spin up a virtual server to run for a while, know that everything is safe and secure if you're going to be working with maybe client information or other sensitive information, but actually then minimizing your overhead costs on sites. So we've been working with customers that are looking to use these as an authentication server because the data is written to a database on the back end. So their authentication service works with their customer data, tokens, and other sensitive information. So they really have this need for this really locked down platform. Another customer has been looking for a secure voice assistant. So something like, Siri, I don't know what Android calls theirs, but kind of, your voice assistant like an Echo or, Hey Google or whatever it is. But they needed it to be in an environment where the cloud admins can't get at the data it's receiving from customers. So there's been a lot of publicity, not too recently, about, Google or Alexa recording, things that it shouldn't be, it's not when you've activated them. So this particular customer wants a secure voicing, wants to know that whenever he will use their voice assistant, that all that information it's getting from their clients won't be accessible by somebody else. It's really trying to protect that. So with both of these customers, they really wanted that enforced storage encryption and separation of trust so that they know that nobody else has access to their client data. I don't know if you guys have heard about, but we announced, I think it was last year, the world's first financial services ready public cloud. So what's happened is we've created through IBM Cloud in collaboration with Bank of America. It's basically just a public cloud that has a secure environment that enables financial institutions, ISVs, or other SaaS solutions to host apps and workloads in the cloud. So it does have an extensive infrastructure. You can run VMware. You could use Red Hat as a service through OpenShift. But the idea is that it's going to be highly secure. It's going to already have, or it already does have, these expected or trusted financial apps ready that you can use. So HyperProtect has been a key part of that. So they already are using, I think it's the crypto services from the very initial onset, and they have been integrating more and more with the database as a service and the virtual servers because they need that secured environment. They need to know that everything is encrypted all the way through and that other people can't have access to it. So HyperProtect has been underpinning a lot of this effort. And this is our last use case, which looks like perfect timing. And you can actually use HyperProtect with the Apple Care Kit. So if you are not familiar with Apple Care Kit, it is a way that healthcare providers can develop applications. So this actually, using them both together, enables the iOS developers to use HyperProtect to protect consumers' personal health information. So the HyperProtect iOS SDK for Care Kit is offering that's available through the Care Kit open source community, and it simplifies integration with our HyperProtect services in the cloud. And there's a little link if you want to see about that. So if you're using that care kit kind of depicted at the bottom to develop iOS for the phone, and we've given you an SDK, it allows you to actually call back to the virtual server and database as a service. And so when you're working with those healthcare customers, you can run your application and store your data very securely and meet those governmental regulations that are necessary for healthcare related information. All right. So we've got a few minutes left. Try to leave some time for questions. But before we go to the questions, so please do submit your feedback. You can do it online. I've given the hyperlink here within the presentation, a little look at what the feedback form looks like, and also the QR code. So maybe if you prefer to do it on your phone, you can scan that. You don't have to try to click on the link or type it in. All right.
All right. Any more questions, anybody? Or any questions? I don't think we've had any questions at all.
All right. And Jeff, I don't know how much you know about the 2020 charity, but they did provide the slide. It looks actually pretty cool. You can consider, since there wasn't a fee for GSE UK this year, if you're able or willing to maybe donate, it's definitely a great way to give back. And
just to just to amplify that a bit further, Mark on his keynote speech yesterday said, if you put £100 or more, you'll actually get a mention from him on his keynote speech. So yeah, there's a little bit of encouragement for you.
There you go. Very cool.
So first of all, I'd like to say thank you. Just for your information, we started off with 16 people. We're down to 13. So I think that's evidence that people have actually wanted to listen and understand what you've talked about. It certainly helped me. I've got to say, a fantastic presentation, Jen. Really, really enjoyed it. And I actually learned something. So thank you for that. The one thing I would add is that the sponsor for this event, believe it or not, is actually IBM are sponsoring this track. So, because we have various vendors that will sponsor ourselves, and without them, we wouldn't have the GSE being put together as it is. So that's very important. Again, I would encourage you to go to the cryptographic session that Sandeep is actually doing, and he introduced it earlier. So please do it. The next session in this room deals with containers, ZOS containers by Steve Warren. So again, if that's something you'd consider, then great. Other than that, it's been a fantastic session, and I'd just like to say thank you. And I'm going to bring it to an end, unless I'm going to give it one more option if anybody's got anything to say.
Yeah,
there's one question that came up.
Yeah, do you want to go ahead, Sandeep?
No, you can take that. Yeah.
Okay, so the question is Docker Content Trust a good way to ensure applications are known and trusted? And my answer to this is absolutely. So when you are working with applications, so whether you're working with an application just in and of itself from source, or you're actually working with it through a container, when you go to, let's say you're using a package manager to install just the application natively, you're kind of unless you specify a specific version, it's a little bit of a wild hair. You don't really know what you're getting. If you're pulling from something like GitHub, you're probably going to get what they've marked as like the master, unless you try to pull like a specific branch if they've done branches. But even then, if somebody's made a change from the last time that you've pulled their code, you may be picking up the code changes, and that may not work for you for what you've built on top of that. The idea with using something like Docker Content Trust, or you can actually, IBM Cloud also has a platform you can use as well if you don't want to use Docker Content Trust. They allow you to basically build an image, and it's going to have a hash ID. So when you go to pull, because it's already built and it's signed, you know that you're getting exactly what it is that you intended to get, and not maybe unintentionally picking up somebody's additional changes that they were making. And this becomes really important for all of us that are working in places that there's hundreds of thousands of transactions, maybe even millions of transactions a second. We want to know when we deploy something, particularly to production, that it is exactly what we vetted and tested, And so this process actually allows you to do that with containers. And only certain people are going to be able to do that and sign it. And only if you have the credentials to actually then pull it, will you be able to do that. And that's particularly important if you're going to have this really secure environment like virtual servers. You want to know that what you put in it is what you know should go in it. And it's not going to be potentially corrupted somewhere along the way.
Thank you, Jen. I don't know if I'm allowed to ask a question.
Yeah.
The one thing that really struck me in your presentation was an awful lot of keys. How easy is it for one, say, individual or one person to actually manage it? Because obviously, if you don't have the keys, you've lost your data.
So within the IBM Cloud offerings, I would say you're happily oblivious to most of the keys. You'll set them up for what you need, but you can use things like the crypto service to manage your keys, and you just know them, kind of by names. When you're working with something like HyperProtect virtual servers on premises, I would say it's a little bit trickier, and I mean that in like the best way. It's where
And that's where secret management comes up.
Yeah, it is. And it's where you might, create a little bit of a spreadsheet to say, okay, I use this kind of key or secret management, but it's going to have these purposes. So that way, when I'm looking at Doc and trying to doing things, I know which I need to go after.
Right. Okay. Thank you. Okay. Any more questions? I'll give it a minute. And if we don't get any, I'm going to bring it to an end. Oh, we must have some more questions.
Yeah, Sandeep, I don't know if you want to talk any more about the managing the keys, because you'll talk about that quite a bit tomorrow.
Yeah, I mean, from a secret management perspective, the number of keys in an environment can grow into the millions if for a fairly good sized enterprise. And when you have several keys floating around, some keys are ephemeral. Virtual servers come up in a IKS environment, and then they die. And for that particular small period of time, you have to manage those keys. The keys are generated, then they go away. So how do we manage that kind of environment where keys are being generated at a pace, and how do we know which key belongs to what lock? So those are the things that we're going to cover tomorrow in secret management session for AZ. So let's tune up to that one.
Yes. So it sounds like that's a session for you tomorrow, Jeff.
Yeah, I was going to say, Sandeep, if I'm not chairing, I'll be on it. So Jen, Sandeep, really thank you very, very much once again. I'm now going to bring it to a conclusion, and thank you.
Thank you.